Hi friends, it's Tim Schrock at Design Build Solutions bringing you today's Tech Tip Tuesday. I wanted to go through this as I kind of alluded to in my short last weekend, short video. I came up with the possibility of creating roof ventilation calculations with a macro. So wanted to kind of briefly share some of the tips and tricks that I found. Let's get started. Before I get going too far, I do want to say thank you all for your interaction, for clicking like and subscribe. I love comments. If you find this information valuable, the interaction is great. I enjoy the comments. If you do find this information, this education valuable, that saves you time and helps you to learn more about Chief Architect, would you consider a small donation at paypal.me/designbuildsolutions? The link's here in the screen and in the description below. So here's the situation that brought it up with this particular project for me. In the past, I've done it before because I haven't had to do multiple calculations. I could just kind of figure out the area of the roof and get it to do what I wanted it to do just once per plan, right? And sure, the calculation was kind of frustrating, but I figured it out once per plan. Didn't seem like a whole lot. This plan, I have multiple single slope roofs, and as you can see here, there's the single slope roof. So I've got to figure out kind of like the number of vents for this ridge and this eave and this ridge and this eave and this ridge and this eave and this, etc. I wanted to come up with one way of doing it, and then I thought, you know, if I can put this in my library, it's going to help me out immensely, even for those single calculation projects. I wanted to show the total area that, so I've got this area, this, and this is a low slope roof, so I still have yet to figure out what I'm going to do with that one. So I at least have 1, 2, 3. This one is low enough that I'm going to just foam it at the underside of the roof sheathing. So I wanted to figure out what this area was, what the required ventilation was, what I thought at one time I may have different intake and exhaust methods, so I might have different calculations for that. So I just wanted to be able to input the total area of the roof, of the conditioned space that was being covered. I wanted to input the exhaust intake and the exhaust, the intake area and the exhaust area. I'm going too fast here. And then figure out, do the calculations of if I'm doing the standard 1/150 or 1/300. I needed to input that. And then I needed to do the calculations. What's the required net free area, ventilated area, in square feet and square inches, and then the macro tells me if it passes or not. Now I have, even though they look the same, I have two ways of inputting this information. The first way, let me go this way, is a macro right here. And you actually don't have to have this variable here at all. We can remove that and remove the equals, just do that code right there. Now, I will have this code for sale. I haven't decided on a price yet, but it is a library object now. I thought I had it as a library object. Yep, there it is. You can just take this and drop it right in there, and there's the information. I've got to update this a little bit, but what this is asking for is NFVA. I'll show you what this is. NFVA.new is important. We need to create a new instance of NFVA. NFVA.new, and into parentheses is the conditioned area, the intake, the exhaust, and then there's a fourth one that's hidden. If you only have three, by default it assumes you're doing the 1/150 calculation. If you want the 300 calculation, then type in comma 300. And you'll notice quickly that the result shows up. The required NFVA 1/300 right there. Changes. So we can erase the 300, and by default it's assuming 1/150. And then you add after the parentheses .calc and end %. Okay, that, let's go into our macros. Vent area. It really doesn't matter what this macro is called here. I just called it vent area, and the class NFVA. Remember that NFVA.new, that's what this is calling here, is a new NFVA class. All right, so to do a .new, it's going to initialize. So we're going to define under the class, we're going to define the initialize method, and that's going to accept the following variables: roof area, intake area, exhaust area, and the area rule equals 150. This area rule equals 150 is where it assumes the default of 1/150. Now, these are just variables that only work within this initialize method. Now we have to put those variables into variables, these local method variables, into a variable that works for the whole class. So we do the at, and what I did was at roof underscore area equals roof area. At intake underscore area equals intake area. So it's taking roof area right here, that's the same roof area right there, and putting it in this. It's not a global variable, it's a local variable to the whole class. The at means it's accessible within the whole class. Just this one class. So the beautiful thing about object-oriented programming is that you can have a class that is this class. So when this text box creates a new class, that's, say, class number 1. This is class number 2. This is class number 3. This is class number 4. Each of these individual variables can be different for each class, 1, 2, 3, and 4. And each of these class variables will then be different as well for 1, 2, 3, and 4. So we've got roof area, intake area, exhaust area, and area rule. And that's the end of the initialization class, method, I should say. I don't know why I put class. That should be method. Now, the method that will be called, remember at the end of that input string in this text box, is define calc method. So this is the method that will perform the calculations, analyze if the ventilation passes or fails, and output the text with the appropriate data. So within this method, we're creating a local variable, a method variable, vent area square foot. So that's grabbing the class variable at roof area divided by the at area rule, rounding it to 2, and that's the required vent area in square feet. And then we want the vent area inches. So we take the vent area square feet times 144, get the ceiling of that. So if it's, let's say it's 741 divided by 150 is 575.1 inches, square inches. It's going to round up to 576 square inches. Then we have the required intake and exhaust are the same. The required intake and exhaust is just the vent area in inches divided by 2. Okay, and I did this because maybe you want to input. Let's do this. You don't know how much intake. I'm going to do this one because that's a trick. You don't know how much intake you need for this yet. Intake and exhaust you need for this 156 square feet yet. And say you only have 50 intake and 50 exhaust. So when you hit the covered area is 156 square feet, this screen will show you, oh look, I need 72 intake and 72 exhaust. I can calculate, okay, I'm going to provide, would we have 112 at each? I could do 112 and 50. Even that passes. But you want a balanced system, right? At least as much exhaust as you can't force air into the intake. So I'm just going to do 112. All right. Now this one, we pulled up this one earlier as the example. The 741, 350, or 360 and 360. You can also create a global variable, say exhaust area 1. So I'm calling out there's 23 vents on this eave, 16 by 8 aluminum vents, 56 square inches each, equals 1,288 square inches for those 23. And the 23 intakes is the same calculation in this case. So I'm calling exhaust 1 equals 1288 inside two parentheses, or I should say $ exhaust 1. $ means it's global, equals 1288. So exhaust 1 equals 1288 and intake 1 equals 1288. And then in my NFVA calculation, I'm telling it 2,668 is the conditioned area, and then I pass into it intake 1, $ intake 1, and $ exhaust 1 .calc, and cover that with the %. And that's pulling, so that's pulling intake 1 from here, pulling exhaust 1 from here, passing that into the NFVA calculations, NFVA class, and that's what it's doing here. Once we've got all of the calculations done, the last thing I've got to do is just pass that information back through text. So I did a text variable, my text equals, start off with double quotation mark. I do spaces so that it looks like, it's a title. And then the \n inside the quotes gives a new line, like a carriage return. And then I do my text equals my text plus further information. Anytime you're doing a variable, you got to remember, one, is this a method variable or a class variable? The class variable is the roof area. That's the information we passed into it. Remember, 2,668, we passed into it directly. We want to report that right back into the plans. So we're going to grab that at roof area.seal. That's seal means ceiling. And the reason I did that, you'll see in a second. That class variable and method variables need to be inside the quotations, needs to be surrounded with curly braces and started with a hash. Okay. A method variable such as vent area SF we did inside this calc method. Vent area SF does not have the at symbol, but it still has the hash and the curly braces. So I did interesting though, area rule doesn't have the hash, doesn't have the curly braces. Huh. Required NFVA using the 1 over, so in this one I just did the hash sign at area underscore rule. That's pulling, remember, the that's pulling the class variable that was from the initialize method earlier. I'm pretty sure the method variables definitely have to have hashes in there, or the curly braces, I'm sorry. So we just report back required NFVA in square feet and in square inches. I report the required intake, required exhaust, they're the same, so I didn't need to create multiple variables for that. That just uses up memory. So I just reported that twice and labeled it separately. Supplied intake, we get that from the call. Remember, the intake area that was turned into this class variable at intake area. Square inches is the text, square inches. New carriage return, supplied exhaust. Total NFVA is total area. That's this variable, which takes intake area plus exhaust area. Now I do a if-then statement. If the total area is greater than or equal to the vent area in inches, then analysis equals ventilation passes. Else analysis equals ventilation fails. My text equals my text plus analysis. Now, I might be able to get by without this final my text, but this my text just says within this method, go ahead and print, if you will, onto the screen, return the variable my text. All of this adds up to my text. End the class, end the method, end the class, and that is that's the end of it. We do need to evaluate it. You don't need context in this case. Click OK, click OK. Now you'll notice I have also a vent area label. And what that is, let's go back into that. Vent area label is evaluated based on the owner object. So I created the possibility also to create a polyline. That could be whatever shape you want. And I'm going to give that line style just a invisible line style. But before I do that, I'm going to specify the label and insert user defined. Actually, you have to know it in your head. So let's go back to line style. I just thought of this. We could do it differently, couldn't we? Just paste that in here and put, instead of a number, just type area. And we don't need area 1. We just need NFVA.new. Right? Is that correct? Oh, I know why it's not showing, because what I did here was polyline labels is turned off. I don't want polyline labels on all of the polylines to show up. So in this polyline, I'm going to go to label and tell the label layer to use a custom layer. And this is going to be text. For me, it's text roofs. There we go. And that did not call it. Let's do this. Label. Area. Oh, that's why it's not working, because area actually has a measurement to it. So we could, so when I'm passing this area, it doesn't, we could do it this way. It doesn't know what to do with that measurement. So let's go into here, vent area. We'll clean this up a little bit, and we'll say roof area equals roof area dot to F. There we go. To underscore F means to float. That means instead of making it a chief architect measurement of square feet, turn that into just a floating integer. And that's all you would need to do. So let's go back and change the line style to an invisible line, and we could put this around, say, that space right here. Ventilation fails, so let's go back into the label and tell it we're going to have 450 intake, 450 exhaust. The bad thing about this is you don't see the automatic feedback of how much, if this passes or fails. You got to click OK. There, it does pass. We could have read the required intake is 386 and the required exhaust done that way. And then you might have to move the label around so that you're not covering up anything. But there you go. You can pass that directly into the what I had set up before. What I've set up with this one here, not that one. I created a new macro. Now that I think about it, I didn't need to do this, obviously, because I just called it a new macro with a different class, NFVA, and that one does turn that. I did the roof area to float here, and then instead of copying the whole calculation method, this define calc, this NFVA.calc method just calls the NFVA method from the other macro. I round robining it a little bit with this. There's some things I could clean up with this. So anyway, that's macros, objects, methods, classes. There is something to consider here when you open a file for the first time. Again, say you've closed the file, even closed Chief Architect, rebooted your computer, whatever happens. But if you close the file and open it back up, you got to think about this. So here's opening up the plan from brand new. Let's switch to the and I say from brand new, actually like from reboot, if you will. Let's switch to roof plan, and you'll notice that the macro is not filled. We will need to remember that we can't just open up the layout and print it. Check whatever layer that you've put the macro on. Like this one is the version that gets the area from the polyline. This one is just the text version. It really works to open up just the text version. Open it up and click OK, and they all seem to work out pretty well there.